Hi, this is Josna. Welcome to Juice Tutorials. Today I am going to say something about quantum numbers. As you know, there are 4 quantum numbers which is used to denote the electrons in an atom. Today we are going to discuss about it. Let's in brief take a note. The first one is principal quantum numbers. The principal quantum number gives the size and energy of the orbit. Look here, as Bohr proposed stationary orbits around a nucleus, the orbits are named as n equal to 1, 2, 3, 4, although they are also known as k, l, m, n, denoted by the letters integers 1, 2, and 3 and 4. This gives the size and energy of the orbit. As the electron enters the higher orbits, it is moving away from the nucleus. And the second one is Azimuthal quantum number. It gives the shape of the orbit. For n is equal to 1, the azimuthal quantum number L takes the value n minus 1. That is, for n equal to 1, it is L equals to 0. For n is equal to 2, L is equal to 0 and 1. For n is equal to 3, L is equal to 0, 1 and 2. For n equal to 4, L takes the values of 0, 1, 2, 3. If L takes the value of 0, the orbit will be spherical. As L takes the values of 1, it becomes a light elliptical. And whereas L takes the values of 2, it becomes more elliptical. And whereas L takes the value of 3, it gives a more elliptical shape. As you can see, they also give the shape of the orbit. L0 means it is S orbit. L equal to 0 means it is S orbit. Whereas coming to L equal to 1, it is P orbit, which is in dumbbell shape. When L is equal to 2, d orbits takes double dumbbell, and L equal to 3, F orbits takes complex structures.
Thanks for watching.
Next, moving on to magnetic quantum number. It gives the spatial orientation of the electrons around the atom, and it takes the values of minus L to plus L along with 0, with making total 2L plus 1 numbers. As you know, S is spherical, it has 0, and for a LP, it is shape of dumbbell, and it takes the values of minus 1, 0 and plus 1. And for d orbit, which is double dumbbell, it takes the values from minus 2, minus 1, 0, plus 1, plus 2, total of 5. And for F, which is of complex shape, it takes the numbers from minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, a total of 7. Look at the S orbit, which is spherical in shape, and P orbit, which is dumbbell in shape and has 3 orientations: Px, Py, Pz, and its shape is dumbbell. And whereas d orbit, it takes 5 types of orientations, and that is dxy, dyz, dzx, and dx square y square, dz square. and it is of double dumbbell shape. And while getting into F orbit, it takes complex shapes ranging of 7 orientations. Now, quantum number 1 gives the L value 0, that it takes the subshell of 1s with magnetic quantum number 0, and the number of subshells in it is 1 with occupying 2 electrons. Look at this. All the 2s orbitals having the magnetic quantum number 0 with subshells 1 and capacity of electrons are 2. And for L is equal to 1, p orbit with 3 orientations, p orbit with orbitals in the subshells to be 3 can occupy 6 electrons in them. And whereas coming into L equal to 2, d orbit showing 5 orientations, that is -2, -1, 0, +1, +2, 5 orientations, that is orbits in subshell to be 5, can occupy 10 electrons in them. While getting into L equal to 3, F orbits shows 7 orientations ranging from -3 to +3 and can accommodate 14 electrons in it. Now on to the final quantum number, that is spin quantum number. In every subshell which can accommodate 2 electrons in it shows the electrons in revolving around the orbit in 2 directions, clockwise and anti-clockwise. For clockwise direction, it is shown as +12, and for anti-clockwise direction, it is shown as -12. These are the 4 quantum numbers: principal, angular, magnetic and spin quantum numbers. That's it for today. And if you like this video, please share it to the needed students and make them subscribe and post a comment of your need.